Here we have a SAT math problem. Okay, let's go to the question. In the figure above, the ratio of BE to ED equals to 3 to 2. The area of triangle BEC is 15 and the area of triangle BEA is 12. What is the area of triangle AEC? So using the given information, we have to get the area of this triangle AEC over here. Okay, now let me consider the two triangles we have over here. They are BEA over here and DEA over here. These two triangles have their bases on the same line segment, that is BD. Okay, here B is the base for the triangle BEA and D is the base for the triangle DEA. And also these two triangles have the common vertex A. Okay, whenever two triangles have their bases on the same line segment and have common vertex, then in whatever ratio we have their bases, in the same ratio we'll have their areas. So the two triangles BEA and DEA have the bases in the ratio, that is BE to ED is 3 to 2. The same ratio will have the area of this triangle and this triangle. Okay, let me write it. Okay, here first we have the number corresponding to B, which is the base of the triangle BEA. So first let me write the area of triangle BEA. Let me write the stuff over here. Area of triangle BEA divided by, now in the given ratio, the next term is 2, which is corresponding to ED. That is the ratio of this triangle DEA. Then we have to write area of triangle DEA. Let me write it. So this ratio equals to the same ratio in which we have their bases BE and ED, that is equal to 3 over 2. Okay, from this ratio, if I want to get the area of triangle BEA and area of triangle DEA, I have to multiply the terms of the ratio by the same non-zero number, say x. So when I multiply this 3 by x, I'm getting 3x, and when I multiply this 2 by x, I'm getting 2x. So this 3x represents the area of triangle BEA and this 2x represents the area of triangle DEA. Okay, here in the given information, we have the area of triangle BEA, that is 12. So that is this x must be equal to 12. When I divide both sides of this equation by 3, I am getting x equals to 4. Okay, now we can plug in this 4 for x over here. Then I'm getting 2 times 4. Then I'm getting 8. So the area of triangle DEA is 8 square units. So now I got the area of this triangle DEA, that is 8 square units. Okay, now my aim is to get the area of this triangle DEC. Once I get the area of this triangle, I can add the area of this triangle and the area of this triangle to get the area of this triangle AEC according to the question. Okay, now we have to have the same discussion. That is, let's consider two triangles, BEC and DEC. They have their bases on the same line segment BD. That is, BE is the base for this triangle BEC and this ED is the base for the triangle DEC. So and also they have the common vertex C. So again the same thing. Since these two triangles BEC and DEC have their bases on the same line segment and have the common vertex, in whatever ratio we have their bases BE and ED, the same ratio will have the area of this triangle and the area of this triangle. Okay, let me write the stuff over here. Okay, so that is area of, let me write it, area of triangle BEC divided by area of triangle DEC. Let me write it. Okay, here I am taking the area of triangle BEC at first because here in the given ratio we have the term corresponding to B, which is the base of the triangle BEC over here. That's why I am taking this triangle first. So the second term, number 2, is corresponding to the base of this triangle DEC. That's why I'm writing the second triangle DEC over here. So in whatever ratio we have their bases, in the same ratio we'll have their areas. That is 3 over 2. Okay, now from the terms of the ratio over here, if I want to get the area of this triangle BEC and area of the triangle DEC, the same thing, I have to multiply the terms by the same non-zero number, say y. When I multiply this 3 by y, I'm getting 3y. When I multiply this 2 by y, I'm getting 2y. So this 3y is the area of triangle BEC and this 2y is the area of the triangle DEC. Okay, already we have the area of the triangle BEC that is given in the question itself, that is 15. That is 3y must be equal to 15. Okay, when I divide both sides of this equation by 3, I'm getting y equals to 5. Now we can plug in y equals to 5 over here. Then I'm getting 2 times 5. 2 times 5 is 10. So therefore the area of triangle DEC is 10 square units. DEC over here, its area is 10 square units. Okay, now my aim is to get the area of triangle AEC. Let me write the stuff over here. Area of triangle AEC. To get the area of triangle AEC, we have to add the area of triangle AED and the area of the triangle DEC. That is 8 positive 10. That is equal to 18 square units. Therefore, the area of triangle AEC is 18 square units. We find this 18 in answer choice B. The correct answer choice for this question is B.